Hello everyone, welcome to TestPrep by InsideIIM. I am Keshav Kumar, a 99.95 percentiler in CAT and a 100 percentiler in IIFT. So today we will be solving slot 3 of CAT 2021 DILR. Let's start with our first set. In this set, let's start by reading it. 3 reviewers A, B, K are tasked with selecting questions from a pool of 13 questions. Questions can be graded by external subject matter expert or by one of the 3 reviewers. Each of the reviewers either approves or disapproves a question that is shown to them. Their decision lead to final eventual acceptance or rejection of the question in the matter described below. If a question is created by an SME, it is reviewed first by Amal and then by Bimal. If both of them approve the question, then the question is accepted and is not reviewed by Komal. If both disapprove the question, it is rejected and is not reviewed by Komal. If one of them approves the question and the other disapproves it, then the question is reviewed by Komal. Then the question is accepted only if she approves it. A question created by one of the reviewers is decided upon by the other two. If a question is created by Amal, then it is first reviewed by Bimal. If Bimal approves the question, then it is accepted. Otherwise, it is reviewed by Komal. The question is then accepted only if Komal approves it. A similar process is followed for the questions created by Bimal, whose questions are first reviewed by K and then by A, only if K disapproves it. Questions created by K are first reviewed by A and then, if required, by B. So what they are eventually telling us is, if S creates a question, then A and B firstly review it, and if they both reject, the question is rejected. If they both accept, the question is accepted. If one of them rejects and one of them accepts, the question is reviewed by K and K's decision is final. If the question is created by A, is first reviewed by B and then by K only if B disapproves it. If the question is created by B, then the question is firstly approved by K, and if K disapproves it, it's reviewed by A. If the question is created by K, then it's first reviewed by A and then by B, only if A rejects it. So that's the story they are trying to tell us. Now let's move on to the next facts they're given. Question 2, 6, 9, 11 and 12 were rejected and the other questions were accepted. Okay, so let's make a table like this. 1, 3, 4, 5, 6, 7, 8, 10, 11, 12 and 13. So what they given is question 2, 6, 9, 11 and 12 were rejected. So that's the information given in the first sentence. I'm marking just cross for the questions rejected and not tick for the accepted ones. That's obvious. Amal reviewed only question 2, 3, 4, 6, 8, 10, 11 and 13. So 2, 3, 4, 6, 8, 10, 11 and 13 were reviewed by Amal and others were not. Bimal reviewed only 2, 4, 6 through 9, 12 and 13. 2, 4, 6 through 9, 12 and 13. Yeah. Okay. Komal reviewed only question 1 through 5, 7 and 8. 1 through 5, 7, 8, 9, 11 and 12. 1 through 5, 7, 8, 9, 11 and 12. So that's the whole story they are given. So let's try to figure out which questions might have been created by who and who might have accepted or rejected the question, said question. Okay. So, see, as the first question is only reviewed by K, that's possible only if B must have created it, and as the question was accepted, K must have accepted the question. Second question was reviewed by all three of them, so S must have created it, and I know for a fact that K must have rejected it because second question was rejected, and I'm not sure if either A or B accepted the question because one of them must have accepted it and one of them must have rejected it. Third question, as it was not reviewed by B, then that means B must have created this question and K must have rejected it because it first goes to review to K, and A must have accepted it as the old question was overall accepted. Fourth question was again created by S as all three of them reviewed it, and K must have accepted it as the question was accepted. Again, I'm not sure about either A or B accepted or which of them accepted or rejected a question. Fifth, again like first, B must have written it and K must have accepted it. Sixth, now here I'm not sure if K wrote this question or S wrote this. Why? Because if S would have written it and A and B both have might have rejected it, the question would have been rejected. And if K would have written it, again both of them might have rejected it and the question would have been rejected. But both the cases are possible, so I'm writing here as S/K. But I know both of them rejected it, so I'm putting cross on the ahead of both of them. Now, seventh question, as it wasn't reviewed by A, so A must have written it and B must have rejected it. That's why it moved to K, and K must have accepted it. Eighth question, again like fourth one, S must have written it, K must have accepted it. Dicey about A or B. Which one of them accepted it or rejected it. Ninth question, A must have written it as he didn't review it, and both B and K must have rejected it. 10th question, K must have written it as only A reviewed it and A must have accepted it. 11th, B must have written it, K must have rejected it, A must have rejected it. 12th, A must have written it, both B and K must have rejected it. 13th, again similar situation to 6th, just differences. S or K might have written it, but this time, see, if K might have written it, A must have rejected a question and B must have accepted a question. Only then the question would have been accepted. And if S would have written it, both A and B must have accepted a question. Only then the question would have been accepted. So I'm not sure whether A accepted the question or rejected it, but I'm sure B accepted the question. Alright, so that's the table we have. Now let's move on to the first question. How many questions were definitely created by Amal? From the table we can see this is the questions created. Okay, so 7th, 9th and 12th questions are definitely created by Amal. So 3 of them. Answer is 3. How many questions were definitely created by Komal? Let's see. This is dicey. This one is created. 10th question is created by Komal. Again, 13th is not created. 13th, I'm not sure. So just one. Question number 2 answer is 1. Okay. Next question. How many questions were definitely created by SMEs? Let's see. Question number 2. Question number 4. Question number 8. 3 questions. Answer is 3. How many questions were definitely disapproved by Bimal? Disapproved. Okay. And Bimal. See, I'm not sure. No sure. Question number 6 is disapproved. 7, 9 and 12. So 4 of them have been disapproved by Bimal. Let's just check it again. Yes, 4 of them have been disapproved by Bimal. See, 4. Okay. The approval ratio of a reviewer is the ratio of the number of questions he approved to the number of questions he reviewed. Okay. Which option best describes Amal's approval ratio? See, how many questions were reviewed by Amal? 1, 2, 3, 4, 5, 6, 7, 8. So 8 questions were reviewed by Amal, and how many them were definitely selected by Amal, accepted by Amal? Question number 3 and 10. So 2 of them were definitely accepted, which is 0.25. And how many them were could have been accepted? Maximum, but could have been accepted If all of them were accepted, and 6 and 11 were definitely rejected, so other 6 could have been accepted. That's a maximum. So my maximum number can be 6 by 8, which is 0.75. So my answer lies between 0.25 and 0.75. How many questions created by Amal or Bimal were disapproved by at least one of the other reviewers? So A or B must have created it and disapproved by one of the other reviewers. So see, let's go step by step. B, this was accepted, not disapproved. This one had at least one disapproval. Question number 5, no disapprovals. Question number 7, one disapproval. Question number 9, both of them disapproved. So this is my 1, 2, 3, third question. Question number 11, both of them disapproved, so 4. Question number 12, both of them disapproved, so 5. Total number of 5. 5 was the answer of this question. Okay, let's move on to our next set. Alright, so this was a toughest set in this slot. So what does this set says? You might have to. This is a long story, so bear with it a bit, I would say. Okay. So there are 10 players, 1 to 10, competing in a javelin throw event. The number after player of a reflects his rank at the beginning of the event. So it's just they are in the order. There were 2 phases in the event, with the first phase consisting of 3 rounds and the second phase consisting of another 3 rounds. A throw is measured in terms of distance it covers in meters up to 1 decimal point accuracy. Only if a throw is valid one. For an invalid throw, the distance taken is 0. Okay. A player's score at the end of the score is maximum distance of all his throws up to that round. Players are re-ranked after every round based on their current scores. In case of a tie in scores, the player with the prevailing higher rank retains the higher rank. Okay. This ranking determines the order in which the players go for their throws in the next round. In each of the rounds in the first phase, the player throws in increasing order of their latest rank. That is, the player ranked 1 at that round, at that point, throws first, followed by the player ranked 2, and so on. The top 6 players at the end of the first phase qualify for the second phase. In each of the rounds in the second phase, the players throw in decreasing order of their latest rank. So, if the player at the rank 6, as the 6 was the maximum number of players in the second round, uh, the player ranked 6 throws first and the player ranked 5 throws second, and so on. The players ranked 1, 2, and 3 at the end of 6th round receive gold, silver, and bronze medal respectively. All valid throws of the event were of distinct distances. So there cannot be a tie. Just note that. The tables below show distances in meter covered by all valid throw in the first and the third round in the event. Okay. The distance is covered by all the valid throw in the first round. So let's write it down. I'm gonna make this P1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6. I'm just creating a grade for right now. Alright. So that's my grade. Yes. Okay. So distance is covered by P1 is 82.9, 81.5 by P3, 82.9, 81.5, sorry, 81.5 was by P3. 86.4 and 82.5. 87.2 and 84.1 by P7 and P9. 87.2 and 80, 84.1. I've just written down the all the valid throws. So that means this must have been invalid, this and this. So these all were invalid throws. Okay. Distance is covered by all the valid throws in third round were P1 88.6, P3 79 and P9 81.4. 88.6, 79 and 81.4. Sorry, that those were for round 3. I'm just gonna have to write it again. 79, 88.6. Correct. 81. Yeah. All right. So this is the information given about the third round. Let me just mark those the other rounds, other people, as all other were invalid. Among the throws in the second round, only the last two were valid. Okay, both the throws enabled these players to qualify for the second phase, with one of them qualifying with the least score. None of these players won any medal. All right. So, who were the last two throwers in the second round? See, as 9 scored, it would have moved up, and 8th and 10th were left as the last two scorers, last two players. So others must have scored 0. The other was invalid. I'm just gonna mark those. And I know for a fact that both of them didn't both of them went for the second round, and they didn't win any medal. So this is for the round 2, and this is for the medals. Okay. Now let's move on to the next information. If a player throws first in a round and he was also the last to throw in the previous round, then the player is set to get a double. Two players got a double. Alright. So what they're saying is that, say in this round as 10th score, 10th through last. Now suppose he would have scored the highest, then he would have thrown at the first in the next round. His throw would have been first, because that's a rule that whoever has rank 1 will throw first, and whoever has rank last will throw last for the first 3 rounds. So if 10 would have done that, it would have mean it wasn't double. So double basically means 2 throws consecutively. Okay, so there were only 2 players who did that. So see, can you just notice that in round alright, let's hold that information for right now. Move on to the next part. We'll come back to this later on. Third part, in each round of the second phase, exactly one player improved his score. Each of these improvement was by the same amount. Now combine this information with the second one. See, if in both all these 3 rounds, 4, 5 and 6, only one player could have improved the score, and what was the order of throw? That last one, the last player threw first, right? And the first player threw last. Okay, so say P10 was threw first in the 4th round. Okay, sorry, yeah, in the 5th round, P10 threw first. Could it have been possible that he would have thrown last in the 4th round? No. The reason being, if he would have thrown last in the first round, that means he was at the first position. Remember in the 4th round, whichever players throw last means he was at the first position. Now, as only one player could have improved his score and the others had the same score or lesser, that means his score would his position could have at best could have been at the second position. He could have been at last in the second position and not any other position. Okay, so even so, then his throw would have been at the second last and not first one. So in round 5 and 6, it's not possible for any player to get a double. Okay, that's what I'm trying to explain. So only doubles which could have happened in round 2, 3 and 4. Now according to the information given, could this have happened in round 2? No, because in round 2, in the round 1, the last throw was by 10 and he failed. So his next throw would have again be the last one. Remember that. And so in round 2 there was no double. I mean in the start of round 2 there was no double. Now both the doubles must have happened in round 3 and 4, right? So in round 3, for the double to happen, 10 must have scored the highest. Only then he would have been able to score through at the first. Na? What was the highest score in the previous till now? 80. And yes, remember that one of them, one of 8 and 10, scored the least as it was given in the first line, first information over here. Okay, as one of them scored the least and the other one scored the highest. Okay, so for 10 to score highest, it must have been greater than 87.2 compared to the last data. 87.2. Okay, only then he would have thrown at the first, right? Now, as 8 has the least score at the end of out of the 6 qualifying players, right? If one, okay, so here's a question. The throw enabled both these players to qualify for the second phase, with one of them qualifying with the least score. So 8 must have scored the least out of those qualifying for the second stage. Now let's see who must have qualified for the second stage. Okay, I'm just gonna increase these lines. Okay, see, P1 has the highest score in this whole data. You can see, yes, 10 might have scored higher than him, but for right now, the information I have, P1 must have scored the highest or the second highest. He must have been there. Third, player 2 didn't qualify, so I will just simply mark gross again with the 4 same. And yes, 8 qualified, 10 qualified. Player 3 had a higher score of 81.5, players 5 86.4, 82.5, 87.2 and 84.1. Okay, so player 7 and player 5 also must have been there, right? Player 5 and player 6 must have been there. Oh, player 5 and player 7, and the last is player 9. So these were the players who were there in the who went on to the second phase of the competition. Okay, so for ease I'm just gonna write their IS scores over here. Okay, I don't need this, don't need this, don't need this, I don't need this. Alright, his highest score was 88.6, 86.4, 87.2, 84.1, and this must have been greater than 87.2. And for 8 to qualify, what would have been his score? See, his score must have been greater than 82.5, because if it would have been less than 82.5, 6 must have been there, and 6 is not there. That means his score must have been greater than 82.5. Also, it must have been less than 84.1, as that's the second last score which qualified. So his score must have lied between 82.5 or 82.6. Let's make it 82.6 to 84. Okay. So that's the information I have right now. All right. Now, in the second phase, exactly one player improved his score. Each of these improvement was by the same amount. All right. The gold and bronze medalists improved their scores in the 5th and 6th round respectively. One medal winner improved his score in the 4th round. Okay. So gold medalist improved his score in 5th round, and bronze medalist improved his score in 6th round, and one of the medalists improved his score in 4th round. That could have been the gold medalist or bronze medalist as well. Okay. Next information, the last one. The difference between the final scores of the gold medalist and the silver medalist, as well as the difference between the final scores of silver medalist and the gold medalist, was 1 meter. Okay. So for a fact, I know 8 and 10 didn't get the medal, so they must not have improved their scores. I'm just gonna mark cross. And 6 didn't qualify, so cross for him. 3 didn't qualify, for cross for that. Alright. So that's the information I have right now. Okay. Can you see what's what's my consideration set? So this is not my consideration set, and this is not my consideration set. These are the four numbers I need to consider right now. Now, for the difference to be 1 in any of these numbers, uh, see, can you see? Actually, let's move on to the questions first. Okay, let's see how many questions we can get from this much information we have gathered right now. Which two players got the doubles? As we already discussed, only two players could have got it. One is player 10 in this round, and player 8. Yeah, we didn't discuss this player 8 na. So yeah, we discussed that player 10 must have got the double in round 3, as he would have scored the highest. And in round 8, as 8 scored the least, I know that 8 scored the least score. So, at the starting of the round 4, he must have thrown at first. He must have thrown at first, na? At the first time, because he was at the last position, and in the round 4, whoever is last is throws first. So, 8 must have thrown 2 times consecutively. Remember that. Out of the given players, they have specifically mentioned that out of the given players only, you have to consider. So, 8 must have got the double in round 4 or at the end of round 3 or at the beginning of round 4. So player P8 and P10 is your answer. Okay. Who won the silver medal? I don't have that information. Who threw the last javelin? I don't. Yeah, who threw the last javelin? I can also tell that why. Because I know 8 had the least score in the group, and he didn't improve his score. So 8 must have thrown at first, and sorry, yeah. No. Sorry, that can't be answered because whoever threw the last javelin must have been the gold medalist. Because his gold medalist improved his score in 5th round, so he must have thrown the javelin at the last javelin of the event. What was the final score of the silver medalist? I don't have that information right now. I'm just trying to see if I can get any information from these questions. Okay, that's sometimes helpful in solving the questions. Okay. Which of the following can be the final score of P8? See, now I know the score of P8 lies between 82.6 to 84. Is there any number between 82.6 to 84? Only one, which is B option, 82.7. So that's my answer. Okay, 82.7. By how much did the gold medalist improve his score in the second phase? Okay, so now I have that improvement numbers. I just wanted this number to make make the question easier. Otherwise, you could have done that, but with a bit of hit and trial. So yeah, you could have done that, but hit and trial would have been needed. Now, using this information, I know either the gold medalist might have improved it by 1 or zero point 0.5, because I again stated in the 4th round we are not sure which player improved his score. So 1 or 0.5, 2.4 or 1.2, 2 or 1, or 1.2 and 0.6. So I have 7 numbers with me technically. Now just see one thing. With the maximum being 2.4, could this P9 be a medal winner? Because even if we add 2.4 in this, it would have been 86.5. And there's no way I can make any of these three even decimal place as an odd decimal place using 2.4, right? And even if I use, as there was just one odd digit, 0.5, even if I use that, it would have been 84.6, and it's no and the difference I need to have is 1, as there was written in the gold and silver medalist. Gold minus silver, distance is 1, and silver minus bronze, distance is 1 again. So there's no way this distance could have been 1 if this would have been 0.5 as it. So I know 9 didn't win a medal, so he didn't improve his score. So that's, I guess, clear till now. So I know either 1, 5 or 7 won a all three of them won a medal. 1, 5 and 7 won a medal. Which one, I'm not sure yet. Let's figure it out from the data. Okay, so let's just see. As you can see, 88.6 is already at a very high number, right? So I'm gonna leave 88.6 a little side for right now and try to bring the difference between others by one. I'm just trying to consider if 88.6 could have been my middle number. Could other numbers have been at this point? Because remember, my maximum increase can be 2.4 and 4.8 respectively, because 2.4 can be the increase of highest one and 4.8 for the gold medal. Like if I take two numbers, three increases were there and all three were similar. All three were with the same distance, same improvements. So if I add 2.4 in this, what would have been my answer? 89.6. And if I add 4.8 here, my answer would have been 91.2, which is not giving me the answer I need, right? And if I add just 2.4 over here, it would have given me 88.8. Again, the difference is less than 1 in between these two numbers. So 2.4 couldn't have been my number. 1 and 2 I'm not trying because I can see there's a decimal point difference of 0.2 in these numbers. So I'm sure 1 and 2 won't work. 1 and 2 meters won't work. 0.5 again would make things ambiguous because I would have to increase all these by 0.5, and that again doesn't help me because if I'm increasing all these three, the difference will never come to be equal to 1. Okay, 0.5 doesn't help me. 0.6 again won't help me because where would I increase it? Simply put it that I increase 0.6 in both of these in this only, that would give me 87.6, and if I increase this by 0.6, 87.8, again it doesn't help. So I'm left with just one option, which is 1.2 meters. I'm taking this data as a reference, but if you would have done it, you can use it. Otherwise, you could have done it by just seeing the numbers. See, 1.2 is the only number which would have made sense because, see, if I increase, as I was just mentioning, 88.6 seems like a middle number. So the other numbers must have been 87.6 and 89.6. And I know the silver medalist, there's no information about silver medalist, whether he improved his score or no. So I'm just assuming he didn't improve his score and his score was 88.6 only. So these are the three numbers I'm targeting. Can I make it 86.4 to 87.6? Yes, by just adding 1.2 over here. And 87.2 to 89.6 by just adding 2.4. And you can see this is double of this. So my improvement must have been 1.2. And if I take the improvement as 1.2 and with this information, if I'm assuming all this, my player 5 must have won the bronze medal with 87.6 as his final score, and this improvement must have happened in round 6 as bronze medalist improved in round 6. Alright. Player 7 must have won the gold with 89.6 meters of throw, and this improvement must have happened both in round 1, round 4 and round 5. So gold medalist improved in 2 rounds with 1.2 each, and that total is 2.4. And silver medalist didn't improve his score, and even player 1 didn't improve his score and he won silver. So that's a lot of assumptions, but some logical, as this question was the toughest one. I am again telling you, even if you would have left it, that still would have gotten you like 99 plus percentile. Okay, so my answer is 2.4 in this question, as they asked me gold, how much did the gold medalist improve his score in the second phase. So second phase is comprising of 4, 5 and 6 rounds. So my answer is 2.4. Okay, Now let's come back to the questions once again. Yes, I answered that 80 to 80 P8 and P10. Who won the silver medalist? P1. Who threw the last javelin in the event? Who was a gold medalist? P7. So P7 threw the last javelin of the event. Who was the final? What was the final score of the silver medalist? Silver medalist final score was 88.6 again. This one we answered, and this one we answered. So this set is done. And again, this was tough one, and it would have taken a lot of time in the actual exam. Alright. Now let's take this question. This was a pretty easy question, and for this you don't even need a copy and pen. Okay. What does the data say? Figure above shows the schedule of 4 employees A, B, D and T whom Dhoni supervised in 2020. Although there were 5 projects which started and concluded in 2020 in which they were involved, for each of these projects and for each employee, the starting day was at the beginning of a month and the concluding day was the end of the month. So no indication over there. And these are indicated by the left and right endpoints of the corresponding horizontal bar, as you can see over here. The data is picture is a bit blurry, don't worry. Number within each bar indicates the percentage of assigned work completed by the employee for the project as assessed by Dhoni. For each employee, his or her total project month is the sum of the number of months he worked across the 5 projects, while his or her annual completion index is the weightage average of completion percentage assigned from the different projects. Okay, with the weights being the corresponding number of months. Alright, so basically completion index is percentage of work completed across the number of months. So if you are working for 5 months and you completed 80% of work, 80% work, and in another project you were working for 5 months and completed 100%. So your completion index is 5 times 80 plus 5 times 100 divided by total number of months 10. Okay, that gives me 90%. For each project, the total employee month is the sum of the number of months for employees worked in this project. Okay. While its completion index is weightage average of the completion percentage assigned for the employees who worked in this project, with the weights being corresponding number of months they worked in this project. Okay. So let's start by reading the first question. Which of the following statement is or are true? First, the total project month was the same for 4 employees. Total project month was the same for 4 employees. Okay, let's just zoom a bit on this diagram. Okay, so total project month for A, and A have been marked with red color over here. All the months have been marked with red color. So total project months of A are these 2 plus 2 plus 1, 2, 3, 4, 5. 9 months. For B, these are green bars. 2 plus 1, 2, 3, 4, 6 plus 1, 2 and 3. 6 plus 3, 9. Again, same 9. For T is yellow bars. 2 plus 2 plus 3 plus 2. Okay, so which gives me 9 again. And for D, the black bar, it's 3 plus 3 plus 2 plus 1, which gives me again 9. So statement 1 is true. Statement 2, the total employee month was the same for the 5 projects. Total employee months, so the number of months each employee were 2 plus 2 plus 2, which is 6. For the second project, it's 3 plus 2, 5. And so they both are not equal, so I can say only 1 is the correct answer. Whichever option say that, in this case it's 4th, so only 1 is the answer. Which employee did not work in multiple projects for any of the months in 2020? Okay, so they are asking me, in a particular month, an employee must have worked in 2 or more projects. So how many number of employees are there who didn't work in 2 or more projects in a particular month? In any of the months, I mean. Okay, so let's take the red bars for the first of A. You can see A, there's no overlapping red bar. As in first case, he worked for Feb and March month. In the second case, in the project 3, he worked for May and June month, and in the project 4, he started work from July till December or November end. So there is no overlapping. So A will be there. In the case of B, green bars, again you can see there is no overlapping in the lines. So B will also be there. In the case of T, you can see there is an overlapping in the case of project 4 and 5 in the month of September. So T must not be there. And in last one is D. As you can see, again there is no overlapping in case of T. As you can see from the black bars, it's just a simple graphic reading. Okay, so there's no overlapping of the bars, so my answer is only A, B and D. Alright, next question. The project duration measured in terms of number of months is a time during which at least one employee worked in that project. Which of the following pair of projects had the same duration? Okay, let's consider the duration of a project. For project 1, you can see there's 3 months, as Tina worked for the first month and first 2 months, and AB worked for the second and third month. So project duration is 3, June to April, March end. For project 2, again the project duration is from Feb to April end, which is 3 months. Okay, so 1 and 2 have the same project duration. Project 3, it's 1, 2, 3, 4 and 5 months from April start to August end. Okay, for project 4, it's again 5 months from July start to November end. So project 1 and 2 have the same number of months, project 3 and 4 have the same number of months, and project 5 has 4 months from September start to December end. So my answer is either project 1 and 2 and or project 3 and 4. As you can see from the options, project 3 and 4 is in the option, so my answer is that only. The list of employees in decreasing order of annual completion index is, okay, annual completion index was weighted average of the number of months and in the percentage of work completed in that project. So let's calculate it for A. 2 times 100% plus 2 times 100% plus 5 times 80%, which is which gives me 800 divided by 9. So A is 800 divided by 9. I'm not calculating this. I will calculate if needed in the future state. B, C, sorry, there's no C, B, D, T, right? For B, it's 2 times 100 plus 4 times 70, which is 480 plus 3 times 90, which is 270 plus 480 is 750, divided by total number of months is 9 again. So 750 by 9. For D, it's 3 times 90 plus 3 times 100 plus 2 times 100 plus 1 times 100, which is 6 times 100, 600 plus 270, 870. 870 by 9 again. And for T, it's 2 times 180 plus 2 times 100 plus 3 times 100 plus 2 times 100. So which gives me 700 plus 860. That's my 860 by 9 is my answer. So they are asking me in decreasing order of annual completion index. So my decreasing order is DTAB. Let's see which option is DTAB. Option number 3. So my answer is option number 3, DTAB. Okay. So let's come on to the last set. Each of the bottles mentioned in this question contains 50 ml of liquid. Okay, and the liquid in any bottle can be 100% pure or can have certain amount of impurity. Okay, visually it is not possible to distinguish between B and I. There is a testing device which detects impurity as long as the percentage of impurity in the content tested is 10% or more. Okay. For example, suppose bottle 1 contains only P and bottle 2 contains 80% purity and 20% impurity. If content from bottle 1 is tested, it will be found that it contains only P, as is evident. If content of bottle 2 is tested, the test will reveal that it contains some amount of I. If 10 ml of content from bottle 1 is mixed with 20 ml of content from bottle 2, the test will show that the mixture has impurity. How? Okay, so 10 ml from bottle 1, so it's 100% purity, and 20 ml from bottle 2, it's 80% purity. So the total amount, if I say what will be my percent amount of purity, is 10 plus 16, 26 out of 30 ml is my purity, which is less than 90%. So anything less than 90% will be impure. 90% purity will be impure. So the test must show I, and which it is. Okay. However, if 10 ml of bottle content from bottle 1 is mixed with 5 ml of content from bottle 2, the test will not detect any impurity. That's again that ratio only. Let's come to the question. 5 ml of content from bottle A is mixed with 5 ml of content from bottle B. The resultant mixture, when tested, detects the presence of I. If it is known that bottle A contains only P, what best can be concluded about the volume of I in the bottle B? So, for the test to say that it was impure, and I know bottle A contains 5 ml of P, bottle B, I'm not sure how much I is there, but the test says it must be impure, and impure is when there is more than 10% of impurity. As I can see, there's 10 ml of liquid in total, 5 ml of this, 5 ml of B. So there's 10 ml of impurity. So I must be more than or equal to 1 milliliter, right, of impurity in this test. So B must have 1 milliliter of impurity out of 5 milliliter of impurity. That's the least number, right? It can be anything more than or less than that, or more than or equal to. Okay. So 1 ml over 5 ml, and what's the quantity of in each bottle? 50 ml. Don't forget that. Okay. So I can simply say, as you can see, there's 20% of impurity at least. I can simply say the impurity must have been 10 ml or more, right? More than 10 ml. So my option A is the answer. There are 4 bottles. Each bottle is known to contain only P or only I. Okay. So it's either 100% P or 100% I. They will be considered to be collectively ready for dispatch if all of them contain only P. In minimum, how many tests is it possible to ascertain whether these 4 bottles are collectively ready to dispatch? Okay. So see, they are asking me if they are collectively ready to dispatch. How can I check that? There are 4 bottles. I'm not sure if how many of them contain P or how many of them contain I. They can, all of them might contain P, or all of them might contain I, or some of them might contain I and some P. So just take this simple example. But now I need to check if they're collectively ready to dispatch and not a number of bottles containing impurity. Remember that. Okay. So for collectively ready to dispatch, if I take 1 ml from each bottle, so what or take, say, instead of taking 1 ml, take 20 ml from each, or 4 ml from each bottle. Okay, 4 ml from each bottle. All right. So if all the bottles are pure, this test must have been passed. There's no doubt in that. Now, if there's just one bottle of impurity in this, okay, so in total I have 16 ml, and out of which 4 ml must be impure, as there's one bottle of impurity. What's the percentage of impurity in this? It's 25%, right? So even if I take equal quantity, I can find, even if there's one bottle of impurity, I can see the test will show me negative, as anything greater than 10%, equal to or greater than 10%. will show the test as negative or that it contains impurity. So I can simply say with just one test, I can tell if it's the order is ready to be dispatched or not. Because if the order is if all of them are pure, only then the order is ready to dispatch, and that only comes when uh, all of them are pure, and I take equal quantity of each. Because even if there's one bottle of impurity, my answer will be 25% impure, and the test will show me negative. So just one test is needed for this. Okay, I hope this is clear. Next question. There are 4 bottles. It is known that 3 of these bottles contain only P, while the remaining one contains 80% P and 20% I. What is the minimum number of tests required to definitely identify the bottle containing some amount of I? Alright. So see, what's my question now? Now again I have 4 bottles, but this time I have 3 completely 100% pure bottles and one with 80% purity and 20% impurity. Alright. Now they are asking me how many tests again I need to see find that impure bottle. This time they are asking me to find impure bottle, not whether they are collectively dispatched. That question is over. I just need to find that which bottle contains some amount of I. So how I am gonna do that? In general, this is a theory. Uh, if you have power of twos, like if you have to do that, a scaling thing, anything with power of 2, as this you can see, the total number of bottles are 4. So, and this is power of 2. So, I can simply say that only 2 tests will be required. If it would have been 5, I would have said that 3 tests would have required. This is a logic which can be used sometimes. You can study it later on. But right now, just a simple way. Uh, Say, take any 2 bottles. Take any 2 bottles and take equal quantity from both of them. Okay. So if both of them are pure, the test will show me pure. Alright. But if one of them is impure, what will be my percentage of impure bottle? Impurity in the test? Like 2 bottles are there, one pure, one impure. What will be my amount of impure percentage of impurity in equal amount, provided they both are taken equally? So it will be half of 20, right? Just using simple averages and mixtures formula, simple percentage. It will be half of 20, which is 10. And if it is 10 or more, it will be impure. The test will show me impure. So this, let's make 2 cases. In the first test, this is my first test. When both of them are pure, I will take the other 2 bottles, which I now know is one pure, one impure. And if both of them are, if one of them is pure and one of them is impure while testing, I will take this set. Okay, so there were two sets. I just erased 2 of them. Okay, I just erased 2 bottles easily. Now one of them is pure, one of them is impure. I know that. So another test, I will just take one bottle from these 2 bottles, test it. If it is pure, that means my this one bottle, another one will be impure one, and if it's impure, that means that is impure one. So only 2 tests were needed in this. I hope it's understood. Okay. So in what I did is 4 bottles divided 2 and 2. If these two were, I weighed these two. If these were, I tested these two. If these were pure, then means the impurity bottle was in this set. Okay. And if this was impure, that means it was in this set. Now, whichever set it was, I weighed. There were 2 bottles. I weighed. I tested one and one, like just one of them. If this one was pure, that means my impure bottle would have been the other one. If this would have been impure, that means I got my impure bottle. So just 2 tests were needed. So the answer is 2 in this case. Last question. There are 4 bottles. It is known that either one or two of these bottles contain only P, and while the remaining ones contain 85% P and 15% I. What is the minimum number of tests required to ascertain the exact number of bottles containing only P? So what they're saying is P and I, there's one or two bottles containing 100% P, and there's two or three bottles containing 85% P and 15% I. Okay, so they're asking me to ascertain the number of bottles containing P. How many tests will it take? Okay, so say if there were two bottles of P. So let's just start with one bottle of P. If this number would have been 1, that means there would have been 3 bottles of I. Take equal quantity again. Take equal quantity of from each of the bottles. So what will be my percentage of impurity in it? 1 times 100 plus 3 times 85. It's easier to calculate the impure percentage. So that's divided by 4. It's easier to calculate impure percent, so I will just do that. 1 times 0 plus 3 times 15 divided by 4 in overall, because there are 4 units in total. So what does that give me? 45 by 4, which is definitely more than 10%, right? So my test will show negative in this case if there's just one bottle of pure. Now if there are two bottles of pure, so what will be my impurity content? 2 times 0 plus 2 times 15 if there are two bottles of impure divided by 4, which is 30 by 4. Can you see it is less than 10? So even if I tested this with equal quantities, 2 and 2 bottles, my test would have shown pure answer. And I know there's just either one bottle or two bottles of pure. So I will take equal quantity from each bottle. If my test shows the negative, I can easily say that there was just one bottle of purity, and if my test shows positive, I can simply say there were two pure bottles and two mixture bottles. So I again need just one test. Just remember, I just did one test and it was clear from that one test. Okay, so my answer is 1 over here. So that's the end of the set. I hope you understood all the questions. Thank you for watching. Good luck.